Okay, so good afternoon, ladies and gentlemen. I'm Jan Lahoda. I work for Oracle, and I normally work on the Java compiler that is in the JDK. And by that, I mean the compiler that compiles the Java source code into the class files. It's dangerous to say compiler in JDK because it usually means hotspot. That's not what I do. I do Java C, compiling just Java source to class files. And today I would like to talk about pattern matching. Yesterday, Ron was talking about why you may be wanting to use pattern matching. And today I would like to tell how to do it in hopefully enough detail. And yeah, I will be talking about some future stuff as well. So we have the fast release cadence in JDK that we release one big release of JDK every 6 months. And 6 months is not really enough time to add some big feature, and pattern matching is a big feature. So we are adding it in phases or in parts. So over the past many years, we are slowly adding new features related to pattern matching. We basically started with switch expressions in JDK 12. And I assume we will continue with adding features, pattern matching features and related features for some time in the future. And today I would like to talk about what's in JDK 21, what you can use now, and what there may be in the future. So what's pattern matching in the sense that we will be discussing today? It's a feature that basically takes some pattern declared in the source code, let's say, and takes the runtime object structure and looks if the runtime object structure matches the pattern. And if yes, it says, good, it matches. It may produce some binding variables. It may take some values out of the runtime object structure. And it say, yes, it matches. And then something may happen. And for here, for questions, we use Slido. So I guess you all know it. I use this qa.geecon.cz, and it works nice. And we are in room 4. OK, and it wasn't the only slide I have, but it was like the only real slide beside the last one that I added yesterday. So it's one of the 2 real slides. Because what I would like to do here is like to actually show you how I can program with pattern matching, what I can do. And my example will be basically a function, a method that evaluates expressions. And for that, I have a parser that takes an expression like this, produces some AST for it, and the AST looks roughly like this. It has some nodes, and one of the nodes is for the add operation, and it has some operands, and one of the operands is a constant, is a literal. The other operand in our case here is another operation, which is multiplication, which again has 2 operands. I hope that's fine. And in Java, I could model it in various ways, but let's say I model it like this. I will create an interface called node, which is general node, a general AST node, and then I will create some subtypes of this node that will represent like the add operation, the multiply operation, the literals, and for this demo I need also the parenthesized node. And these have like the operands, right? So the add node has the left and right operand. That are again some nodes, some AST subnodes. And here I'm using 2 features, and it's not by accident. We need them. And one of them are record classes. Record classes are basically simple holders for data that are immutable, or at least the references to the data are immutable. You cannot, once this add node is created, you cannot change the left field in that class. And these record classes are basically expanded to ordinary classes by Java C. I don't want to get into too much detail, but we can maybe look that there is some constructor equals hashcode generated for us, accessors for the components, and so on. And the second feature that is not exactly pattern matching, but is related, is sealing. And if I mark an interface as sealed and then list some types as permitted, then these listed types are the only subtypes of node that are permitted, the direct subtypes of node that can exist. So if I would go here and I would like to add a div node for division, the compiler should come to me and tell me, no, you cannot do it, because div node is not permitted by node. And we'll see why this is important later. And now, like the example, as I said, is that we have the AST, we have the expression that is parsed into the AST, and we want to know the value, the evaluated value of the expression. And we could do it like this. Basically, we have a node, and we ask if it's an add node, then evaluate the left subtree, the right subtree, add the result, return it. We are done. And it would work. It definitely would work. But there are some problems. It's not really nice to write like this. Among other things, we are repeating this add node type here 3 times. And if I would write mul node here, I will only find out that there is a problem at runtime, or maybe when ID tells me that it's problematic. So one of the features for pattern matching that we added some time ago is pattern matching for instanceof. And technically, this is a pattern. It's called a type test pattern because it checks whether the expression is of the given type. And if it is of the given type, it will create a new variable called an, and it will put the expression into it. And so I think this is nicer. You may ask, why not reinterpret n as add node here? The practical reason is that if we would do this, it would change meaning of existing programs. Because the type may be part of method overload selection, so we could select a different method overload, which is probably not a good idea. And anyway, like the pattern matching is not only this. There is more to pattern matching than just this. So yeah, we need to create a new variable with the correct type here. We cannot retype the variable in the expression. And yeah, I can change this all, and maybe I will change the names to be shorter. And now there is a little bit side note that is not completely related to pattern matching again, but it's interesting. You cannot ask this question. You never could ask this question because the compiler statically knows that there is no instance of string that could ever be node, because in the hierarchy of string is final, and in the hierarchy of string class, there is no interface node. So this is like applicability for instanceof. With sealing, you cannot even ask, for example, if n is instance of number. Number is not a final class, but node is a sealed class, and we know that in the sealed hierarchy of node, there is never a number. So we cannot ask this. This is somewhat relevant in some cases than for switch exhaustiveness. And now, like first topic that may be a little bit harder, and that is scoping. Because what we see here, we can say here that, okay, there is the variable introduced and it's valid inside this block. And it's sort of true, but it goes further. So what I can say is something like this, and then use the variable inside an expression. Because the mechanics on which this works is that the instance of expression introduces the an variable if the expression is true. So if the expression is true, I can use it. I can use it here. And then, of course, we have like special provisions for ifs, which is basically what we have seen so far. So I can write this, because I can only get to the then section of the if the condition was true. So every variable that was declared when true in the condition is then declared in the then section. It's not declared. If I write it like this, it's not declared here, because I can get here when the condition is false. I can get here when n is definitely not an at node. So you cannot use the variable here. And you cannot, in this case, use the variable here. There is a trick there is a very tricky thing, and that is if I make sure I will never return from the else, I can suddenly use the variable here after the if. It's leaky scopes, probably leaky scopes is the polite way to describe this. So you can basically say if after if I could only get here if the condition, if the instance of was true, then it's declared. Of course, so we could try to write like this, right? Some preconditions of methods. If there is, if n is an at node, then do nothing. If it's not an at node, exit. We probably don't want to write code like this. Let me see. So in practice, we can write like this, which means the same, because the node will flip the is declared when true to is declared when false, and it all works. So what I mean by all this is that there is support for pattern matching in if, but it's not very special cased. It's relatively general built way to do scoping for binding variables. And also something similar works for loops, but it's a little bit more complicated for loops. Okay. Now, we actually have this pattern matching, for instance, for a pretty long time. I don't remember the release. I think JDK 16. I mean when it was final, so that you could use without enable preview. Since JDK 21, you don't need to do this like instance of cascades, because it's not really nice to write like this. So let me first copy this so that we can see the new code and the old code, at least partially. So starting from JDK 21, we can write switches which do pattern matching. And I may repeat this a few times more, but this basically works in a very similar way. This will, as the cascade of ifs down here, it will take the selector value is this, and it will try to match every pattern in the case, one after another, basically. And the first one that matches, and some other conditions are fulfilled, which you get to later, then the block will be executed, and nothing else. Just the first one that matches, and all the conditions are fulfilled. Only that single case will be executed. And yeah, let me delete this. It basically meant the same. You know that before this, switches only supported ints, enum constants, or enum types and strings. Nothing else could be selector of a switch. So this is basically a little bit new kind of switch, and this new kind of switch has some special restrictions. And one of the restrictions is that we need to cover all the possible input values. So if I don't have like default, and we definitely know that node had literal node as permitted subtype. So we definitely know that, okay, not really nice. So we definitely know that there is a subtype of node that we could get here that is not covered. So this is an error now for switches, even for statement switches. It was always for switch expressions, it was always an error to not cover all input values. Because for expressions, you need to have an answer for every possible input value. But you don't need default necessarily. In this case, if the selector type is, in this case, sealed, it's enough to cover all the possible variants. And that's enough to make the switch exhaustive. That means it covers all input values. For some definition, covers all input values that we get to a little bit later. And just as a side note again, you cannot ask like questions that don't make sense. Like, we know that there is no node that would be a string, right? And there are cases where like with generics where you cannot say so easily that some type is not applicable for switch, as that it cannot match the given expression. Okay, and I would probably rewrite this to a switch expression because it's easier and it's shorter and it means the same. And it means the same. Should mean the same. Okay. And now, so this is nice, but it's also sort of boring. Let's look here. I actually don't really care about the literal node, right? I don't care about this ln. I don't care about it at all. I only care about the value, about what's inside of the literal node, what's the constant, not about the node itself. I just match, I know that it's the node, and then I need the value. So what I can use, so far we are using the type test patterns, and now we will use a different kind of pattern, and that is a deconstruction pattern. That is a pattern that will say, if the value against which I am matching is of this type, then please deconstruct the type into elements and take these nested things as patterns and continue pattern matching. And to answer one potential question, these nested patterns are positional. There are no names. It's the components of the records that you need to repeat in the same order. You don't need to repeat the types. You can use vars inside the deconstruction patterns, and it will infer the generic type, basically, or the general type, not necessarily generic. And now let us convert the mul node as well to see how this works. So I can deconstruct the multiplication node into left and right subtree, then evaluate the subtrees, multiply the results, and return it. Now I could go one step further, and that is I can add some additional condition. So not only when the pattern is matching, but I can say, and when some other condition is met, and we call these other conditions guards. And we can say in this case, and if nested is a literal node, and the value of the literal node is 0, then don't compute anything and just return 0, like this. And so I can add some additional conditions. As we are discussing the scoping, I can use any variable that was any binding variable that was declared inside the guard in the body of the switch statement of the case. But in this case, of course, I want to use 0. But as I was saying, like in the deconstruction pattern, this is another pattern. It's not something hard-coded, it's another pattern. So I can basically nest the patterns like this. So I can have a deconstruction pattern which nests, and inside which there is another deconstruction pattern nested. And it means the same. If like there is a null node, the left component is literal node, and the value is 0, then return 0. And yeah, and that is. Now, the switches have some special things. I was talking about the exhaustivity. We will talk about it a little bit more. And exhaustivity is actually like, I hope it's natural to understand for people, but it's specified in a really strict way. So there is a very specific and strict way how the exhaustivity is specified. And I hope it will be like approachable by people. But there is another concept in switches, and that is a concept of domination. And as I was saying, like the switch basically searches for the first case whose pattern matches, and the guard will evaluate to true. And that will be the only case that is executed, unless there is false true, which is possible in some very, very, very rare cases. But let's not go there. But typically, only one case, or at most one case, will be executed. And if you look here, like whatever node I have that will match this, it will also match this. So if I would put this like more general pattern in front, then like it would match everything, every null node, and this would be never executed. So the Java compiler will not allow me to do this, because it will tell me that this pattern is dominated by some preceding pattern. This pattern will never be, or this case will never be executed, because some pattern above already covered the case. So the order is important for cases, for pattern matching switches, the order of cases. Okay, and now the favorite topic of everyone, and that is null handling. Because that's very, very specific for pattern matching. So let's get into it. The declaration of the parenthesized node, and this is why I need a parenthesized node, is that it has nested node, just one, to keep things simple. And then I have like two patterns, two usages of patterns, one this, and the second one this. And there is like a conceptual difference between these two patterns. And the conceptual difference is that whatever is nested in the parenthesized node, this will match it. If it's an at node, this will be okay. If there is an at node, it will be okay. If there is a literal node, it will be okay. Whatever can be nested in the parenthesized node, this pattern will be okay with that. So we call this pattern unconditional. This pattern is not okay with everything. It's okay only with at nodes. And the very big difference between these two patterns is that this pattern will also match null. So for this case, what we see here, we see that we declare n here to be parenthesized node of null, and then we ask the instance of, does this match this pattern? And if I run it, and let me check if I have the correct main method. And if I run it, then after a moment, it will tell us result, it's true, it matches. In this case, I didn't want to say matches because, you will see why later. But if I type at node here, it will say no, this is not true, the instance of is false. And it basically, it's that unconditional patterns match null. But this is like the pattern matching view of the world. The complication is that the instance of operator has some long-standing behavior and long-standing opinion on how to behave with nulls. So if I will do this, put null directly inside the narrator inside the variable, and then, okay, this must not be this, but I will do it like this. Then it should tell me it's false, because like instanceof, when the expression was null, instanceof was never returning true before, and it's still not returning true. But this is not a pattern matching thing. This is the behavior of instanceof, because there is no pattern matching happening in this case. Instanceof, the operator itself will say no, because and the expression is null. And the distinction is important, because now the next step is switches to make things a little bit more complicated. And you may know that the long-standing behavior of switches is different. So the behavior here is also different. Like this. I will keep the is true and is false. Yeah, and in this case, it's actually covered. Yeah. And in this case, the selector value is null, and the switch will throw a null pointer exception. This was happening since JDK5, since switches started to accept strings, enums, and boxed integers or boxed numbers. There is a new feature that we can say case null, and this will be executed when the value is null. So we can see that the null pointer is no longer like hard-coded. It only happens if we don't do some action. We can handle the null selector ourselves if we want to. And now the most tricky thing. Yeah, let me return a deconstruction pattern here and nest it like this, and let me uncomment this. So now the selector value is not null, but it's parenthesized node that contains null, and the nested pattern is unconditional, so the result is true. And now I will make those things really complicated, and I apologize that I have to. And I will expand this case into 4 cases that will cover all the possible variants. So null node, literal node, and parenthesized node. Now, we know that the parenthesized node contains some node. We know all the subtypes of node, and all the subtypes of node are covered here, one by one. The only value that is not covered is null. And so there is a question whether this should or should not be exhaustive. And the answer is that this switch is considered exhaustive, because otherwise, like, the null would need to be handled by absolutely everybody everywhere in a lot of cases. So what happens if I run this? Because there is null, right? And the reality is that there will be an exception, a new kind of exception that is match exception, that basically is thrown in case where the switch is exhaustive at runtime, but not exhaustive at exhaustive at compile time, but not exhaustive at runtime. And there are a few cases where it can happen, and one of them is the null handling for record components right now. So I don't know if that scared you. If yes, I'm sorry. So what I was talking about so far are features that are in JDK 21. You can try them. You don't need any enable preview or anything like that. You can use them. If you use JDK 21, you can use them. If you will look here, we have this case where we handle the case where we have 0 times something, and we return 0. And if you will look here, we actually don't care about this right variable at all. in JDK21, you unfortunately need to write a name of a variable here. But there is a preview feature in GeeCON that may become final at some point, a final feature, that you can use underscore here. And that means like, I must write something here because otherwise I wouldn't have enough nested patterns, and because the nested patterns are positional, it would break. But I don't care about the value. And the underscore can be used on a few more places. It can be used as a lambda parameter. That's maybe the most important, I would say, in local variables, if you need to declare a local variable without name, exception parameters, let's say. In rare cases, it may be okay. And on a few other places, you cannot use it in an API. You cannot say like something like this. The compiler will tell you, no, you didn't want this. You didn't want this. Because like in APIs should be documentable, and the underscore is not documentable. You cannot write a Java doc. If you have 5 underscore parameters in method, you wouldn't be able to write Java doc for that. So that's one of the reasons. Basically, you cannot use underscore anywhere where it could be an API. So, and inside patterns, you don't need to type var underscore. You can just use underscore. That's a special type of pattern that will match anything and will not produce any variables, any binding variables. I guess like you mostly know it from other languages. So this is a preview feature in GeeCON, and I think it's the only one pattern matching related feature in preview feature in GeeCON. Now I would go a little bit further. What some of my colleagues are working on, and I may be working on that as well in the future. And one of the new features is patterns for primitive types. So in JDK21, if the component is a primitive type, this pattern, the type in this pattern must exactly match the declaration. There is, like, if in JDK21, if I would type byte here, it would tell me, no, you cannot write this. It must be int. In declaration, it was int. It must be int here. But one of my colleagues is working on primitive patterns, and they work in a way that I can write byte here. And then I can do, I don't know, multiply bytes. And the semantics of this is very interesting. And the semantics is that if the value inside the literal node, the actual value at runtime, will fit into byte, then the pattern matches, and the variable is created and so on. If the value will not fit into byte, the match will fail, or like the match will not succeed, and we will continue with further cases. So basically, if there would be 1 times 2, this will match, because the values are small enough. If it will be 1,000 times 1,000, this whole pattern will not match, because like 1,000 will not fit into a byte. And it might be used maybe to produce a different code if you are multiplying bytes versus multiplying ints or something like this. Okay, and now another topic. It's not as hard as nulls, but it's really interesting. So let's imagine we had this AST in some version 1, and in version 2 we now realize that we would like to have some positions for the nodes. And how do we do it? Yeah, and there is one thing that I didn't quite tell, and I'm sorry for that. Right now, to use deconstruction patterns, you need records. You cannot do it for ordinary classes. It must be records. So now we want to add some positions to the AST. So what do? I create a new component for the record, because I cannot create a new field inside record. fields inside a record must be its components. The problem is that now I broke everyone who is creating a new instance of a literal node, and I broke all the deconstruction patterns everywhere because they use only one parameter, and now there are two components of the record. So the compiler says, no, you need to have two nested patterns for this deconstruction. For constructions, or for constructors, it's easy. I will create a new constructor. I will delegate to the canonical constructor, filling out the value, -1, whatever I want, that's fine. So that solves the construction issue. It does absolutely nothing for the deconstruction issue. So one thing that we are working on, but it's probably far away still, is a way to declare custom ways to deconstruct objects into components, into elements. I don't want to show you how the declaration is, because that's likely to change. There will be a discussion about how that should work. But I can show you how it would be used. So let me try to enable the deconstruction for the literal node. And now I added something that can split the literal node into one component, which is what was there before. And my switch is happy again, because I can now say literal node and just one component. Even so, the literal node can have two components. I can use only one. And now there is another feature that's somewhat a pattern matching feature, or pattern matching related feature that is somewhat related to this, but it's not exactly this. And that is, let's imagine now that we have the AST with positions, and we, for whatever reason, want to delete the positions from the AST. Let's not speculate why. And so what can we do? We can take the nodes, we can switch on them, and because the records are immutable, we cannot change the values, we cannot reset the values inside the nodes, but we have one instance of the AST, and we can create a new copy of the AST on the side with the positions removed. So that's basically what this code does. If the node is literal node, it will create a new one, copy the value, reset the position to -1, and copy all the other nodes, cleaning positions as it goes, as it creates the nodes. And what we may be able to do at some point is to use a reconstruction expression, which looks like this. And it basically means take ln, split it into components, deconstruct it into components, create local variables for the components with the same names as the record components, then execute this custom block, which can reassign some of these components, and at the end create a new literal node based on the component values. So in this case, we copy the value, so we don't need to do anything about the value. It will just be copied from the old ln, and we reset the position, whatever the position was. And let me try to do it on, that's a little bit more tricky, on this at node. Maybe it will be more clear how this works, and I need to do it like this. And like this, this, and this. So basically, at this opening brace, the at node is split into left and right component. Then we clean the positions for each of these subtrees and reassign the left and right variables. And at the end, at the closing brace, the at node is reconstructed from these new values. That's another thing we are looking at that may happen at some point. If it will happen like this, I am not completely sure, but it's something we are looking at. So this is all about this demo, and I said I have a new slide, and the new slide is this. So Java, there were always good ideas for Java. You may have seen I am using NetBeans. That's my option. I know that many of you are using a different ID, and like these IDs are like really good and big and used, but in some context, some other maybe simpler IDs are used. Like I was told that Visual Studio Code is used in education a lot. So what we did is that we created an extension to support editing Java source code in Visual Studio Code. It's based on Apache NetBeans, which is based on Java-C. The parsing inside NetBeans is done by Java-C. So in a sense, whatever Java-C does, it's inherited in NetBeans. And on Wednesday, this was published on the VS Code Marketplace as Java Platform Support. So yeah, you are welcome. You are welcome to try and tell us what you think about that. And maybe this was my last talk where I used NetBeans to do demos. Maybe I will use this from now on. So that's basically it. And there are questions. Okay. Is there a shorthand notation for deconstruction of records into their components without having to sort the components explicitly as var left and var right? Not really, not really. There is one thing, the names do not matter. So you could say var L and var R, and that's okay. But you need to have as many nested patterns as there are components inside the record. If you don't care about some of the values, you can use, or you will be able to use underscore at some point, but you need, yeah.
Can I follow up? Because in your clean positions, you actually used left and right on the right side of the expression, and they were meaningful. They meant the left, essentially, and you didn't have to declare.
Yes, it was in the, what I was showing, it was in the reconstruction expression, in the this expression. When this will be done, if it will be done this way, then yes, but it's not what's in JDK 21 right now. It may be possible to do it at some point. When, I cannot tell. If it will look like this, I don't know. It's still like in progress. Okay. Okay. Was it? Yeah, there is one thing I forgot. Was the technical reason for supporting matching only on records and not on arbitrary classes? I would say no strict technical reasons. We just don't know how to declare the deconstructors. Once we will have the deconstructors that I was showing, it will be possible to do deconstruction of ordinary classes. But the deconstructors are, I would say, relatively complex. So it's work in progress. And the idea is that once it will be possible to declare a way to split a class into components, it will be possible to do it for custom classes. In the cross-section pattern, why do we need types var at all? Couldn't absent. So there are two parts of answer for this. For deconstruction patterns, in general, what's nested is another pattern. So you can say, I don't want everything, I want only some part. But if you use var, it will automatically infer the general type. And the reason, I would say that there are two reasons why var is required. And like everyone can agree or disagree. One is potentially some readability. And the other one is that the syntactic way that you just say some name may be used for something else in the future, which wouldn't be possible if we allowed like just left there or just name. there. We couldn't use the notation like this for something else. So it's var name for now, because I think we want to be able to do something with this syntax like just name. Maybe not, I don't know, but maybe nothing will happen. But I think it's good to have the option to do something with this syntax. Okay, I said that one case match, that only one case in the switch will be executed. Okay, so if there is no return, no break, and it's the colon switch, then in principle there is a fall through. But if there are any, and it may happen even for pattern matching switch in very rare cases that you can do actually fall through from one case to another, but technically only like one case will be executed and it will fall through to the other. But there are so many conditions under which this can happen that this is like unlikely to be like useful in practice, because if you have binding variables in the second case, you cannot fall through to a case which has binding variables. So there are like many conditions which must be met. Otherwise, like fall through in pattern matching switches will in most practical cases simply not work, and the compiler will say that this cannot be done. Like if you have case which creates a binding variable and under that you have another case which creates a binding variable, you cannot fall through from the first case to the other. Compiler will say that this cannot be done. And it's because like the second case, you can use the binding variable there. You can print the binding variable. But if you would fall through from the upper case, it wouldn't be declared. Never was, this variable was never assigned to. Does the VS Code plugin follow language server protocol? Yes. Can I use it on Vim? Not completely sure right now, but I would like to take a look at that. In principle, it should be possible. If it's possible right now, I don't know. When will you return deconstruction pattern for 4? Okay, there was a feature that you could use in for each deconstruction pattern, and it would like deconstruct all of the values through which we were iterating in the for each. This was removed. I believe that there is another idea that we could have match statement, but that this deconstruction pattern in for each would be part of this, but the match statement is in very early stages. I would say in so early stages that I didn't want to even show it here too much. Are there reps for deconstructions and reconstructors that you can check and follow? Not right now, I believe. Yeah. Can we use after keyword? Like you, I'm pretty sure you can use whatever operator you want. It's expression. If it will do what you want, that's a different question. But like you can the flow scoping of binding variables is declared well only for double ampersand and double or. So if you want some binding variables to be usable in the expression, in later parts of the expression, you cannot use just single ampersand. But if the expression doesn't need this, you can use whatever you want there, I believe. I am not aware about any limitations here. When we pair with subtypes, we already know about the subtypes, and that's strange. No, that's the point. Like the declaration of the interface or class says, I know about these subtypes, and I say that only these are my subtypes that I care about, and no one else should subtype me. That's like, I think Ron was yesterday telling that before this, you either had like unlimited subclassability or like final, and nothing between this. sealing is like, you can say that only this part of word can subtype me, but no one else. So I would say, on the contrary, that's the point of sealing, that you know about all your subtypes. Or like all your direct subtypes. The direct subtypes can have more subtypes in their hierarchy, of course. So yes, I guess that's it. Okay, thank you for your attention.